What's going on, everybody? Mr. Diamond, and we're back following up with that question that I asked at the end of the last video, which is when we talked about ketones, which I'll click back, notice that we had numbers. So like this one here had 2 pentanone. It was a 1, 2, 3, 4, 5 carbon chain, so that's penta, and on position 2 there was a ketone, so it became 2 pentanone. Now, this is because our naming conventions that we've been using aren't actually perfect. So the demonstration or the idea that I left you with was how many possible ways can you connect 6 carbons with single bonds? And the answer to that question is there are 5. 5 possible options to make hexane, a 6-carbon chain, using only even just the formula C6H14. Even getting that specific formula. You have it as a straight line. You have it where there is on the first carbon a bump thing kind of coming off of it, or a carbon chain coming off of it. You have on the second or the third carbon, sorry, this is the second carbon, because here's first, second. On the 1, 2, third carbon, they're coming off. Here we have a kind of triple branch at the very beginning here instead of just this one branch. Here we have this kind of weird branches on either side. So that and if you're thinking that something might be able to be another option, it's probably one of these just if you flipped it or if you rearranged it in a certain way. So these are the 5 possible options. And the whole point of naming is that when you name something, you should be naming one specific type of molecule. So this obviously does not work because they are not naming one specific type of molecule. So our normal naming rules only allow us to name based on parts and not on structure. We've got to come up with something new that we can use to help us name the structure. And to do that, we have to thank the International Union of Pure and Applied Chemistry, otherwise known as IUPAC. They are the most widely recognized method of naming organic substances, and this is going to be our set of rules that we're going to talk about. We'll be adding a couple more pieces as we go through the semester. Not really too many more, though. Most of what we're going to hit here with the basics will be a lot of what we're really going to use for the rest of the semester. Okay. So rule number 1, identify the longest uninterrupted carbon chain. We will call this the parent chain. The parent chain is where you base your root naming off of, and then you get to identify all of the substituents. Substituents is just the word for groups that are coming off of the parent chain. Then you number the carbons of the parent chain from whatever end results in the lowest numbered substituent. So for example, looking at this, you might go, well, we can number it 1, 2, 3, 4, 5, 6, 7. But if we numbered it from the right instead, here we would have 1, 2, 3. The third carbon is where we would have our first position or our first substituent. But on this side, on position 1, 2. On position 2, we would have our first substituent. So we would actually number this from the right. We would go 1, 2, 3, 4, 5, 6, 7. So make sure that you keep that in mind, that just because you're given a molecule a certain direction does not mean you can just number it from left to right. You've got to check. Some of them may not even be on the horizontal axis at all. Some of them may get numbered like starting down here, come up, come over, and then like come up some other part of the molecule. So make sure that you're keeping that in mind. This is rule 3A. If there are any side chains that are equal distance, then you choose the end that would come first alphabetically. So, for example, here on carbon from this direction, carbon 1, 2, we would have a chain, and here on carbon 1, 2, we would have a chain. This is a 1, 2 carbon chain, so that's an ethyl. This is a 1 carbon chain, so that is a methyl. Because E comes before M in the alphabet, we would number this from the left, because alphabetically this chain would come first. Rule number 4, if the same substituent happens multiple times, you get to identify each point it occurs by using the number, and then you add the appropriate prefix from the covalent compound rules that we've used to it. So 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is pent, 6 is hex, 7 is sept, 8 is oct, 9 is non, and 10 is des. So if there are 4 methyl groups, it would be tetramethyl, and you just have 4 numbers telling you at what 4 locations those methyl groups are found at. Number 5, if there is more than one substituent, you list them alphabetically, ignoring the prefixes. So ignoring all of these, just what is the root of the type of substance that you're looking at. So iso is the only prefix that gets excluded in alphabetical determination, and we're not really going to work with iso. That's just going beyond what we are really going to care about for the class. Number 6, if you need tiebreakers for any of these rules, here is the order of the tiebreakers. First, the chain with the greatest number of side chains wins. So if you're trying to figure out, okay, these are both made out of 8 carbons, pick whichever one would have the greatest number of side chains. Number 2, the chain whose substituents have the lowest number. So if you number it from one direction and you number it from the other direction, they both have like a methyl on carbon number 2, but from one direction there is another methyl on carbon 3, and the other one there's not a methyl until carbon 5. You would number from the side that will give you the lowest total number. Third tiebreaker is the chain with the largest number of carbon atoms in the smallest side chain. So you find whatever the smallest side chain is and count the number of carbons in that. And then fourth, the chain with the least branched side chains. You are basically never going to get this far, so don't worry about needing that rule. And then 7, if the carbon chain forms a ring, we add the prefix cyclo in front of the name. Now, I'm going to explain that in a little bit more detail. So for numbering cycloalkanes, you can do clockwise or counterclockwise because the molecule, if you were to look at it from if it's a circle, remember this is 3D. We're looking at it from one side. If we looked at it from the opposite side and we were facing out of the page, basically, we would see the mirror image of the shape. So clockwise versus counterclockwise doesn't actually matter. You just want to pick the method that gives the lowest total number. So in this example, we're going to name using the alphabetically first group as the lower number in the tie. So if you can't figure out which one way to number from, just pick the one that's alphabetically coming first. And in this one, we have ethyl as a substituent, and then we have alcohol group down here. We have an alcohol group attached to it. So I'm going to number it. Ethyl comes numerically first because it is alphabetically first. So I'm going to do 1 ethyl, and then position 1, 2, 3, there is an alcohol group. So we didn't actually see an example like this in the earlier ones, but you can actually put the number right in front of it if that makes more sense to you. This could have also been 1 3 cyclopentanol. All of those would be, or either of those would be okay, but in this case we've got a alcohol group, so the ending becomes OL. And then the circle, or the ring, is 1, 2, 3, 4, 5 carbons long, so it is cyclopentan. So again, this could have been 1 ethyl 3 cyclopentanol, or you can break it up and say 1 ethyl cyclopentan 3-ol. Either of those is okay. Where exactly you position the number is kind of up to you. Now, the other way more complex rule that may only come up once or twice in this chapter and in future chapters is that when you name a substituent that isn't just a methyl or an ethyl or an alcohol group, you can basically use the naming rules and name the substituent inside parentheses. So in this case, we have 1, 2, 3, 4, 5, 6, 7 carbons. And then on position, since it's symmetrical from both sides, on position 1, 2, 3, 4, there is, well, it's not an ethyl. It's 1, 2 carbons or 1, 2 carbons this way, but it's 3 total carbons. So what we're actually going to have to do is we're going to have to say that on position 1, 2, 3, 4, and then in parentheses, we start numbering the first thing that wasn't the parent chain. So starting numbering right here, we would say this is a methyl ethyl because it's 2. And then, or it is an ethyl group because it's a 2-carbon chain. And then on this first carbon, there is a methyl attached to it. So if this would be a 4, ignore the rest of the molecule and only start here, methyl, because there's a methyl on position 1, ethyl. And then the rest go back to the rest of the molecule, and it would be 1, 2, 3, 4, 5, 6, 7. So that would be heptane because there's no double bonds or no triple bonds. Okay, that's a whole lot of rules. We're going to call this video, now that you've kind of got the rules, I've got a bunch of examples, like a ton of them. For this chapter, we're only going to be concerned with alcohols, ketones, and aldehydes. So don't freak out about amines, amides, anything like that yet. They'll come up in the later chapters. But I've got just a bunch of like draw these structures based on names. And then I've also got a bunch of pictures that are examples that we'll kind of go through together in class. And then I will also make videos going through all of the examples as well. So you don't have to worry about those of you that aren't in class. You'll be able to see all of the examples. And you'll be able to have them as extra practice if you want to use them as extra practice. But that is all for this video. This is Mr. Diamond signing off. I hope you guys have a great rest of your day. Any questions, remember, shoot me an email for them. I hope to see or hear from you soon.